Data project topic is understanding clouds from satellite images. First, I'll introduce you some background. Shallow clouds is an important indication of Earth's climate, but it is difficult to represent in climate models because the organizations of cloud are various and murky. So we want to build better models to classify cloud organization patterns to understand how clouds will shape our future climate. Here are our methods. We pre-process data using Python and Spark SQL. As for image segmentation model, we use Google Cloud Platform Compute Engine and UNet algorithm. And then we use Flask, Google Data Studio, and BigQuery to get our final interactive website, which will be shown later. Our dataset contains 6 gigabytes satellite images. We have training data, including more than 5,000 images, and also a CSV file, which is about the chain image indices with 4 label names: sugar, fish, flower, and gravel, each corresponding to the picture below. And encoded pixels are also provided for each label in each image. And we also have testing data, and the testing data only has images, about 3,000. Most of the images contain at least 2 types of those clouds. And then I will show you how we pre-process our data. For each image, we have 4 records corresponding to the 4 types of cloud. And first column is the 4 types, and the second column is the encoded pixels of each image. And take this one as an example. This image shows the fish and flower types, but not gravel or sugar. We want to get these two graphs. First, how often each type of cloud appears, and also the second one, frequent patterns of the cloud formation. So we get this final statistic table showing each pixels with the labels that exists, and also the frequent patterns of this image.
Image segmentation is inherently pixel-based classification task, and so the cloud organization pattern segmentation is pixel-based cloud organization pattern classification. So UNet is one of the best model for image classification tasks, and we use the UNet with pre-trained backbone ResNet34. It takes satellite cloud images and return pixels related to each class of cloud in the image. We also have post-processing method, which we use ResNet 101 to perform image classification based on the existence of 4 types of cloud in the image. This will help to improve the accuracy by removed pixels missegmented by UNet. So this is a tool we used in our project. So we use Keras for neural net construction and training. Also, we use Pandas for data processing, and OpenCV for image processing, and Skitlearn for the training process, and TQDM for visualize our training process, and GCP Computing Engine is our training environment. The upper image is the label for segmentation. So for each class of cloud in the image, we have the corresponding encoded pixels. For the post-processing classification, we transform the encoded pixels into using one hot encoded label. The below one is the image for the one hot encoded labels. So to evaluate our segmentation model, we use dice coefficient. This can show the similarity between our predicted pixels and the ground truth. So we applied balanced cross-entropy dice loss as our loss function for the UNet, and this is the equation. The left-hand side is the best model we have in terms of the loss, dice coefficient, validation loss, and the validation dice coefficient. The right-hand side is the plot of our training process. The first picture is the loss and the validation loss versus epochs, and the second one is dice coefficient and validation dice coefficient versus epoch. This is the training process of the post-processing classification model. And the left picture is the main precision recall AUC, and the right-hand side is the binary cross-entropy. So this is a plot, the precision recall plot for each class of cloud for the model of post-processing, and the best model we have achieved a mean area under the precision recall curve of 0.791. So our output of UNet will produce the encoded pixels for each type of cloud in an image, and below is the visualization of the output encoded pixels.
After building the model, we used Flask, Google Data Studio, and BigQuery to build an interactive website to present our project result. This website includes two features. First is an interactive data summary report. Then user can upload the cloud image to experience how our model works. Next, let me show the demo of our web application. This is a home page. Here shows our project's objective and data source. Then we embedded the Google Data Studio summary report inside the website. It gets data from BigQuery directory and draws these charts. As you can see, now there are in total 5,556 images and 11,864 clouds. If you want to check the distribution of frequent patterns for those images who have only one type of cloud, just click the pie chart. Then all charts will update automatically. In the Classification Models tab, user can upload cloud image. Click Submit. The model will run at the back end to find cloud types in the segment, and it will also store the new result into BigQuery. This process usually takes 30 seconds. Okay, here's the result. It shows this image only has one type of cloud, which is flower. Then if we go back to summary report, you can see it's already updated. This is our final project, and thanks for listening.